Hello everyone, welcome to our channel Zeal for Python by RB. Today we are going to learn about dynamic typing in Python. Here we are going to cover the topics missing declaration statement, how objects determine types, what is garbage collection, shared reference for mutable object, equality check for shared references. If you all are familiar to Python, you might have noticed that there is no declaration statement in Python, which is generally seen in languages such as C, C++, and Java. Everything in Python is treated as object and stored in memory location. In Python, different types of object is determined during runtime. It will never be declared before execution. This concept where the data type of variable is determined by type of value contained by the object is called dynamic typing. Let us see with the help of an example. I'll take a variable year and assign value 2020 to it. Most of you will expect an error, but the code runs successfully without error. This is called dynamic typing. Here let's check its answer. It gives us, correct value 2020. What exactly happens here? Here, year is a variable name which is stored in system table and the value is stored at the different memory location. As soon as code year equal to 2020 is executed, a chunk of memory is allocated for value 2020 and the system table has a space for variable name year along with its reference. Year will point or refer to the chunk of memory containing object 2020. This link is called as reference link. This object contains two types of standard headers, type designator and reference counter. In Python, the type designator header marks the object's data type. To check the data type of object, we use method type. Let's check the data type of our variable year using method type. It gives us int as a data type. This means 2020 is type integer. Take another example where I have a variable name with value zeal of Python. Check its data type. It will give me value as string. This means str string is stored as in type designator as its data type. Let's see about another header called reference counter. Here in this picture, as you can see, variable A is referencing to variable object 5. Variable B is referencing to object 6. Variable C is referencing to object 5. Here, as you can see, I have written C is equal to A. This means C is referencing to the object 5, which is also referred by an object A, by an variable A. Here, if you can see, both variable A and C are referring to an object 5. This is why the reference counter has value 2 because two variables are referencing to it. On the other hand, variable B is referencing to object 6. There's only one variable pointing towards 6. Therefore, reference counter has value 1. If we change the value of A and C, they will no longer point to an object 5. So the reference counter will turn to 0. Unless the object is referred somewhere else. Okay, when the object is not referenced by any variable and reference counter is set to 0, the space assigned to the object will be reclaimed. This is called as garbage collection. Benefit of garbage collection is that we can freely use object without the need to free space in script. Again, if we want to check reference counter, use method getRefCount, which is stored in module sys. So in order to check, we will have to import first sys and then use sys modules method getRefCount. For here I will use a variable year. See, it's giving me value 2. This means two objects are pointing to an object 2020. This is just for reference. In actual, the number of references can vary depending on the actual number of objects created in the memory of target system. Now let us learn about shared references. What is shared reference? In previous example, we have seen that A and C variables were referencing to same object 5. This is nothing but a shared reference. When when a same object is referred by multiple variables, it is called shared reference. Keep in mind that shared references works differently for different data types, that is mutable and immutable. For both the mutable and immutable objects, the shared reference will work differently. Let us consider an int. Consider here we are taking another variable current year, which will point towards 2020 itself. See, we will check here, value of year is 2020 and for current year it is also 2020. Now if I change the value of year to 2021, what will happen with current year? It will remain same. This is because as soon as I change the value of variable year to 2021, it no longer refers to 2020. A new object with value 2021 has been created in another memory location. And it points towards now 2021. But the current year still points to 2020. This is the case with immutable objects. Immutable objects doesn't change. When a variable is referred to another object or some another value is assigned to the same variable, they are create a new space in memory location. But this is not the case with mutable objects. If a mutable object changes, the change is called in-place change, means it changes in the same memory location. And all the variables referring to it also changes. Let us see with the help of an example. We will take your list as our example. I will take list. This is my list 1, and I will refer list 2 to list 1. Now check the value of both list 1 and list2 both are same. Now if I change the value, change list1, I will change index 0 of list1 to 10. Now if I check, my list1 is changed to 10, 2, 3, 4, which is different from original list1. If I check now value of list2, it is also the changed one. But this was not the case with our year and current year, because those were immutable objects. Mutable objects, they are changing in place, so both the shared references are changing. Now if you want to avoid this, if you don't want this to happen, we have an option wherein we use a built-in function copy from copy module. Let's see how it works. If I create another list, list3, first I will import my module copy. Now I will create my another list, list3, with of L1. Sorry, list1. It will give me list3 same as list1. Now again, if I change the value of list3 index 1 to say 43, my list3 will change, but sorry, still list1 is this list. I'll again create a list4. Sorry, I changed list3 in place of list1. Copy dot deep copy and same as list3. I want list4 same as list3. See, list3 and list4 are same. They are reference list3 and list4, but list3 has the list4 is of copied version of list3. So now if I will change list3 index 1 to say 23, my list3 is this, and list4 which I created from the copy method will remain same as list3. This means if we use the copy version, if we use copy module, we don't change the shared references. We can prevent changes in shared references. Now if you have to check the shared references equality, means if the two lists are same or not, if they are same object or not, you have two methods. One is equal to and another is the is method. Let's see. I will first check if list3 is list4. False, because we created list4 with the help of list3's copy, not the same object. Copy is created in another part of the memory. List, it is not the original one. That's why it gave us false. Now let's see, for list1 equals list2, it's giving true, because here we didn't use a copy function, we just copied it. And even if we changed list1, the same change was reflected in list2. I hope you all understood the basics of dynamic typing. This is all we have for dynamic typing. If you have any questions or suggestions, please let us know through comments. Also, please subscribe to our channel to get notifications on further videos of Python knowledge. Thank you.